A pump will transfer stored water to the places you need it. It does this using a delivery system comprising three main elements: suction, pumping equipment, and discharge. Suction requires a shut-off valve, strainer, and 1-inch flexible hose. Pumping equipment includes a pressure system in the form of a pump and a controller to make the system automatic. Discharge relates to the pipes and plumbing fittings that lead out from the pump, as well as any taps, hoses, sprinklers, toilets, and washing machines. Before you purchase your pump, it's important to do your research. Every garden is unique, and so are the people who tend them. The wrong pump can leave you frustrated and out of pocket, where the right pump will make gardening a breeze. A retiree with a small townhouse garden will have different needs to a young family on a half-acre block. So how do you know what's right for you? Firstly, there are a few pieces of terminology that are handy to know. You will hear the term head mentioned when dealing with pumps. Head is simply an expression on pressure. In a tank where the water level was 1 meter higher than the outlet point, a pressure gauge would show 10 kPa of pressure, which is 1 meter of head. Every meter of water height equals 1 meter of head. 1 meter of head is equal to 10 kPa. kPa, meter of head, and psi are all units of pressure. Discharge height refers to the vertical difference in height between the pump and where you want the water to go. For example, an elevated garden, rooftop, or hanging baskets. The demand pressure is the pressure needed by an outlet, such as a sprinkler, to function properly. Without adequate demand pressure, your sprinkler will not work very well. The exact demand pressure required will usually be stated on the product packaging. Flooded suction describes when the water level in a tank is above the pump inlet. Suction lift means that the water level is lower than the pump. It applies to underground water storage tanks that are serviced by an above-ground pump. Friction loss describes the pressure used to push water through pipes. The speed of the water traveling through the pipe, the diameter of the pipe, and the distance the water is traveling are all contributing factors in working out how much pressure is needed to do the job. The internal surface area of your pipe can make a huge difference too. In our example, we will be using polythene pipe. When the diameter of the pipe is increased, friction loss is reduced. More water can flow through the middle with less touching the walls of the pipes where friction loss occurs. When the pipe diameter size is doubled, the actual area of water flow is increased fourfold. A friction table is used to determine friction loss, expressed in meters of head per 100 meters of pipe length. This pipe friction table demonstrates how an increase in pipe diameter can reduce friction loss dramatically. If we select a flow rate of 23 liters per minute and our pipe diameter is ½ inch, the chart shows the friction loss would be 90 meters for each 100 meters of pipe. If we keep the flow rate the same but doubled the pipe diameter to 1 inch, friction loss reduces to only 3 meters. That's a huge difference. Now that you're up to speed on the lingo, the next step is to learn how to calculate pressure requirements.